So we are Team 50, and our project is the Kinetic Dispersion Tester. Little introduction to our project and our team. We have Trey Stroop. I myself am Griffin Miller. We have Juliana Reyes, Dalton Weber, and Brent Dardine. So for this project, we wanted to see what can be done to create a repeatable experiment for testing the force distributed from a bullet in soft tissue. U.S. manufacturers and testing facilities need a more precise and repeatable method for testing bullet impacts. Existing techniques fall short of achieving kinetic energy dispersion data. Our work will include creation of an apparatus containing accelerometers to map bullet impact data as energy is dispersed through the ballistics gel.
For our testing system, we're making use of a piece of electrical conduit, 5/8 electrical conduit, to maintain the accuracy of our stand-in projectile since we can't test at a live range. For our projectile, we're using 1/2-inch rebar cut at a length that equals around 2 pounds, and then we sharpened one side to reflect that of a boat tail projectile and the other side to reflect that of round nose ball ammunition, with the goal being that this would best simulate practical ammunition during our testing.
So using the 2-pound projectile, when dropped from a height of 7 feet, will result in a energy amount of 25 joules upon impact of the ballistics gel. And when we observe this on the video for the first video and the second video, it is easy to tell when the impact happens that there are oscillations being measured in the ballistics gel that can help us to determine the force dispersion throughout the ballistics gel of either a ball projectile or a boat tail projectile during real-world testing.
So here's an example of the type of results we're getting. We have a 3-axis accelerometer. So you can see that's what each line represents, one axis of it. And as the projectile hits, we have a spike initially, and then as the oscillations continue, they taper down. And in our final iteration, we will include multiple of these accelerometers so we can see how that dispersion changes as we get further into the block of gel.
Which relates to the bullet's trajectory through a ballistics gel. As the bullet travels through the gel, it will disperse energy differently throughout different parts of the gel.